Hello and what's up guys, Medium Guy here. Welcome to the next video in the Caddy video series, and in this video we're going to see how to implement correlation ID for our requests that will be processed by our Caddy server. So if you want to learn more, stick with me. So by default Caddy is not supporting this, and actually there's an external module that we can add to our custom instance of Caddy server to actually be able to use this module and add a header that will have some unique value for exact requests and responses that will be sent back to our clients. So as you can see, I'm in the GitHub repository for the Caddy request ID module, and if I move down, you can see the syntax of how we can actually make use of this external module. So initially, the thing that we have to do is to build our own custom image of Caddy server that will have the Caddy server in itself, plus this module added to its list of modules. So first thing, I'll move to VS Code right over here, where I've got my configuration files prepared in order to demonstrate this whole thing. And as you can see, I have a Docker file in which I'm using the Caddy's builder image as my base image, and by using the xcaddy build command and by adding the exact address for the GitHub repository that we just saw, I'm able to actually build my own image of Caddy server that also has the Caddy request ID module included in it. So next, I'm using the Caddy's official image with some recent tag as my base image and copying the Caddy that is built in my previous image and replacing it with the Caddy inside this official image. So first thing, I'll move to terminal right over here. I'll hit ls to make sure I'm in the exact same directory which holds all my configuration files. So I'll put all these configuration files in my GitHub repository, for which you can find the relevant link down in the description section if you want to follow along. So first thing, I'll try to build my image out of my Docker file. So I'll say docker build, and by saying -t I should be able to give the newly creating image a name and a tag. So I'll say Caddy with the exact same tag that I am using as my base image, and I'll put a -request ID at the end, so later I will know that this exact image is actually including the request ID module inside it. So I'll put the dot as the context for my Docker file, and lastly I'll hit enter to let the Docker do its things and actually go ahead and build my image with my desired modules included in it. So I'll give this time and come back whenever it finishes. So as you can see, my image is built, and right now I should be able to create containers out of this newly created image, and I'll try to nano the Docker Compose file. Right over here you can see that I've got a backend service that is actually an echo server that will be responding with the detail of whatever request that it will be receiving. So next, right over here, I've got my Caddy service that is using the same image that I just created, and over here I'm setting the restart policy to let the Docker engine know that it has to always maintain the ops status for this Caddy server container. So next, right over here, I've got the environment variable section, and by setting the time zone, I'm actually able to set the time zone inside the container that will be created. And right over here on the port section, I'm mapping the port 80 and 443 to exact same ports inside the container, and I don't know why did I put this extra port right over here. So later we'll see that I will configure the Caddy in the Caddy file to listen to this exact same ports. So eventually the clients will use my host machine's IP address on these two exact ports to be able to communicate with the Caddy server that will be running inside a Docker container. So lastly, right over here, I've got the volume section that I'm mapping the Caddy file right next to my Docker Compose file to this exact path inside the container, so that the Caddy will try to look for this file to initially configure itself when it's trying to come up. And right over here, I've got the ./data and ./config directory mapped to /data and /config inside the container to actually persist whatever data and configuration that the Caddy server will create. So I'll save and move out of the nano, and next I'll try to nano the Caddy file. So before explaining the Caddy file, I'll move back to the readme of the GitHub repository. Right over here, you can see the exact syntax that we can actually use in order to make use of this request ID module. So we can pass things like the length or the key and length configuration for this module in order to define the length of the request ID header that will be added to our requests that will be processed by the Caddy server. So by default, it will use some defined name for that exact header, and actually by passing the key with this exact syntax, we can actually tell this module to actually set the header name of the request ID that will eventually hold our unique ID for each of our requests. So using this exact same syntax right over here, I'm actually setting the request ID and I'm passing a name with a length to the request ID module, and right over here in my handle block, I'm actually trying to match all the requests to this exact pattern, which is /API/whatever. So right over here, by using the header directive, I'm actually setting the header name and using the http.requestid.header, which is exactly the same name that I passed to the request ID module. So as a result, a header will be added to my requests with this exact name and with this exact length, with some unique value, of course. So lastly, I'm using the reverse proxy directive to proxy the requests to the address of the backend on port 80, which is exactly the same name that I provided for my echo server in my Docker Compose file. So because these two containers will be created using the same Docker Compose file, they will actually be attached to the same Docker network, and as a result, these two containers will be able to see each other and communicate with each other through their Docker Compose service names. So I'll exit out of this nano and try to create my containers using Docker Compose up-d, and as I'm expecting, my both containers with a network should be created, and by saying Docker Compose ps on the status column, I can make sure that both my containers are in up status. Of course, with the exact same ports that I defined in my Docker Compose file mapped to each of these two containers. So by saying Docker Compose logs-f to follow the logs and --tail 100 to grab the latest 100 lines, and as I can see, things are looking good, and right now I should be able to make requests to this Caddy server running as a Docker container. So I'll move to another terminal right over here. I'll try to make some requests using curl, and I'll provide the address of the host machine that is running my Caddy server's container on the path/API. So I'll hit enter, and as I can see, a request ID header is added to the headers of the request that is being sent back to me as a client that initially made the request. So right now, as you might already noticed, the request ID header is not sent from the Caddy server to our backend server, as we can see right over here. So this JSON right over here is exactly the detail of the request that is being sent by our Caddy server to our backend server. So as we can see, this request ID header is not included in the headers of the request that is being sent from the Caddy server to our backend server. So in order to fix this, I'll move back right over here. I'll try to nano the Caddy file again, and by using the header up directive, I should be able to add this exact same header to the request that will be sent from the Caddy server to my echo server. So I'll try to use this exact key and this exact value, and actually instead of header, I'll try to use the header up directive to actually add this as a header to the request that is being proxied to my echo server. So I'll hit save and exit out of the nano, and I'll say Docker Compose down and Docker Compose up-d to actually remove my currently running containers and create these two containers from new which will hold my updated Caddy file inside the Caddy's container. So I'll try to move back right over here. I'll try to make another request again using curl. And right now, as I can see, the request header is included in the response that is coming back to me as a client, and also the exact same header with the exact same name is included in the request that is sent from the Caddy server to my Echo server proxy behind the Caddy server. So that's all for this video. I hope you learned something new in this one. If you haven't watched the previous videos, I recommend you give a visit where you can learn about some basics of reverse proxies and some other cool features like rate limiting, load balancing, and cool stuff like that. So if you want, you can find the relevant link to the Caddy playlist down in the description section of this video. So if you found the video useful, please don't forget to like and subscribe to my channel, which will help grow the channel and motivate me to create more free contents like this. So with that, that's all for this video, and I hope to see you in the next videos.